Okay, let's talk about compound interest some more because, it's an important topic. And if I were to rank things that you need to know as a beginner, well, compound interest would be on top of the list. Anyway, so far the compounding period that we discussed was the yearly or annual compounding, meaning, the interest that you earn will be added to your principal and then recalculated every year. So your money will be compounded one time, right? Now, we want to talk about frequencies other than annual compounding. And the main ones are, well, first of all, annual compounding. Like I said, that means your money will be compounded one time, right? Then we have semi-annually. That means your money will be compounded every 6 months. So twice a year, right? And then we have quarterly compounding. That means your money will be compounded every 3 months. So overall, 4 times a year, right? And then we have monthly, that is 12 times a year. And remember, we also have, daily compounding and continuous compounding. But, for the beginner's course, I'd rather not talk about those because in terms of daily, yes, we have 365 days a year, but, there are different conventions for how many days in the year you want to count. And in terms of continuous compounding also, the whole formula changes. So let's ignore those for now, and these are the big ones anyway. Now, the formula that we know and we are familiar with is the FV, future value, equals PV, present value, multiplied by 1 plus R to the power of N, right? This is the compounding, how we calculate the compound interest in the previous videos, right? So R was the stated interest rate that we know it's stated as an annual rate. And then N is the number of periods from today. Are we talking about 10 years from now, 20 years from now, right? But this formula is not complete. And if I were to complete it, I have to do this. I have to divide R by M and then multiply N also by M. Now, what is M? And why didn't we have it so far? So M is the number of compounding periods. And because so far we were dealing with annual compounding periods, and annual compounding is just, one compounding period. So we can just ignore it. I mean, anything multiplied by 1 or divided by 1 is the same thing. So we can just ignore that. But since now we're talking about compounding periods other than annual compounding, for example, in the case of semi-annually, right? So we have to adjust our interest rate that we know it is a stated annual rate also has to be adjusted according to our number of compounding periods. So if you're talking about semi-annual compounding, that means our R, whatever that is, has to be divided by 2. And N, also whatever that might be, must be multiplied by 2. If you're talking about quarterly compounding, this 2 has to be 4, right? Divided by 4 and then multiplied by 4. So let me rewrite this. All right, PV, present value of the investment, whatever we're starting with, FV, future value of the investment, N, periods from today, R, rate of interest per period, M, the one that we just added, number of compounding periods. And it's pretty simple, really. Let's do one example so we know what we're doing here. Let's say you have $10,000 and you want to invest that in a certificate of deposit, and they tell you that they will give you the interest rate of 10%. And it is compounded for the sake of simplicity, let's say semi-annually. So your M, the compounding periods, will be 2. And you want to know what will happen to your money, what will be the future value of your money after 3 years, let's say. So N will be 3. All right, so let's use the formula. $1,000 multiplied by 1 plus R, 10%, decimal way, 0.1 or 0.10, doesn't matter. 0 here doesn't matter. So to the power of 3, right? But because it's a semi-annual compounding, we have to adjust R and N, right? So this will be divided by 2, and this will be multiplied by 2, right? So this becomes 0.05, and this becomes 6. I'll do it again here. So that would be $10,000, I'm sorry. multiplied by, when I add up this one, 1.05 to the power of 6. So let's get the calculator out. Okay, so this becomes 1.3400. Then multiply by 10,000. The whole thing becomes $13,400 and some change. So that's the future value of $10,000 if it is compounded semi-annually with a 10% interest rate after 3 years. So 3 years, 2 compounding period per year, overall 6 compounding period, right? Okay, great. And I really encourage you that whatever example we're doing, you can also do the annual compounding of the same thing and see what will happen in terms of the difference. Or we can do different time periods. For example, do the same question for after 20 years, 30 years. What I'm trying to say is that play around with these formulas so you can understand these small changes can have extreme effects on the future value if we are talking about a longer period and the more compounding period we have. So overall, 2 things will affect your future value. Obviously, the interest rate is the main one, and after interest rate, also the number of compounding periods. So these are the 2 factors that will affect your future value. The higher the interest rate and the more compounding periods, the better. Let's do another example. Let's say you are the winner of your state lotteries of $5 million. You invest your winnings in a 5-year certificate of deposit or CD. The CD promises to pay 7% per year compounded annually. How much will you have at the end of 5 years? So this example should be a good review because we are dealing with the annual compounding, but let's do it anyway. So 5 million is our PV. Let me write it out. PV 5 mil. Then we have our R is 7%. And what is our N? We want to know what will happen after 5 years. 5. And our M, I'll write it anyway, compounded annually, so our M is 1. All right, so let's use the formula. That will be 5 multiplied by 1 plus decimal way, 7%, that will be this way, and then to the power of 5, and our M is 1, so divided by 1, multiplied by 1, the same thing. All right, now let's get the calculator out. That will be 7.012, and if we wanted to add, multiply it by a million because we dropped it here, that will be $7,012,000. So your 5 million with a 7% interest compounded annually after 5 years, you will end up with $7,012,000. Simple enough. If it was compounded semi-annually or quarterly, again, we would just adjust our R and N. And if it's quarterly, we just multiply by 4, and this one divide by 4. Let's do another example. Suppose your bank offers you a CD, certificate of deposit, with a 2-year maturity. Again, if you're not familiar with these terminologies, please go and see my fundamental of investing videos, where I briefly explain what these terminologies mean. All right, so suppose your bank offers a CD with a 2-year maturity, a stated annual interest rate of 8%, compounded semi-annually. All right, so we want to use, let's say, the same present value. Let's say we want to know about this 5 million. And all right, so our PV, we assume that's 5 million. Stated annual interest rates, our R is 8%, and 2-year maturity, so after 2 years, N is 2. Semi-annual compounding, our M is 2. So that will be 5 multiplied by 1 plus 0.8 to the power of 2. Then this has to be divided by 2. This has to be multiplied by 2. Again, 5, 1 point. This becomes 0.4. 0.4 to the power of 4. Okay, calculator. That will be 5,849,292. Okay, again, try to play around with this formula. Try out different number of compounding periods, and also play around with the duration, like 30 years, 40 years, and then compare.